around, you probably weren't there when we were going around talking about our projects, but you know, we do have quite an investment in the Messinet program out here in the Muscle Shell. And so people would probably like to make a connection with how you are tied to that, which you were probably going to talk about anyway. But anyway, you can do whatever you want. You're on.
Awesome. Well, thank you guys. And just real quick, can you guys see my screen just fine?
Yes,
good.
We can.
Okay, awesome. Awesome. Well, thank you guys again for having me. My name is Zach Hoylman, and forgive my Grizz flag in the background. Most of you are probably cats, but we are based out of the University of Montana here in the Montana Climate Office. And I'm excited to be here today to talk about some of our recent work. And this talk, you know, I'm going to give it kind of an overhead of this idea of navigating the waters ahead, and really describe some of the efforts we've been doing to address research of climate change in Montana and some improvements to our drought and flood early warning systems across the state. And my name is Zach Hoylman. I'm the assistant state climatologist at the Montana Climate Office, and I'm also a research assistant professor at the University of Montana. And a lot of my work has focused in the past on understanding how forests kind of respond to climate variability and change, and understanding how hydrology, I'm really a physical hydrologist, how watersheds move water and energy through ecosystems and impact how forests grow, how rangelands respond to climate variability, and more recently, kind of looking at how to enhance our drought monitoring infrastructure across the state, and doing some research on understanding how to define drought in the context of a changing climate. So to start, I just wanted to start by giving some regional perspective that you guys obviously are very, very well accustomed and understand, but Montana is in a really unique geography. We are called the crown of the continent in a lot of ways, and we're called, you know, the headwater state or triple divide. And this is because, of course, Montana sits on kind of this intersection between three of the major river basins across northern America. Of course, the Columbia River Basin, the Saskatchewan River Basin to the north, and then the Missouri River Basin. And you guys are probably most interested, of course, in the Missouri River Basin, given where your group kind of is geographically. And actually, that's good for this talk because a lot of our work has been focused on the upper Missouri River Basin and looking at conditions kind of east of the divide. And so when we look at this map and we see that how much of an area Montana's headwaters kind of impact in terms of water resources, it really kind of underscores the importance of understanding how to manage these water resources under the context of change, and in the perspective of course, agriculture, livestock production, etc. And so when we think about this question of how do we manage our water resources for seasonal, annual, or decadal drought, or changes in water supply, of course, we think of the agricultural sector, the livestock sector, and think about how we might kind of make important data-driven decision-making to basically help buffer our water resources given kind of seasonal changes in availability. And when we think about agricultural systems and livestock systems and management of water with relation to those systems, the first question that I think of is the first kind of need is we need to know where and when to manage. And that's something that the Montana Climate Office has really been in collaboration with many other folks, including IOE, folks like Kathy Whitlock and others from MSU, have been really kind of building a lot of our research repertoire and some of our climate data services to try to understand this question of where and when to manage our water resources. And when we think about that kind of need, really what we're talking about is monitoring. And when we think about Montana, it's a very diverse state, of course, as we all know, from the Rocky Mountains in the west to some of the Great Plains to the east. We have kind of a very large, diverse kind of geographic scope, different landforms, different ecosystem types. We're talking from rangelands to forested ecosystems to high alpine environments like up in the Missions, et cetera, and in other mountain ranges, right? So we have a very diverse state. And what that means is that we need a whole lot of different resources to accurately monitor conditions across the state, being things like satellite data sets. For example, these are measuring cloud cover and where precipitation might be falling, or vegetation responses to drought and water surplus, right? Large scale changes to land cover, maybe large woody encroachment into some of our rangelands, and large scale atmospheric data sets and models, things like kind of like what Kathy was talking about, utilizing these large global circulation models to understand where precipitation is falling, temperature regimes in different locations across the state. And one of the key kind of parts of all of this monitoring effort, before we start jumping to the satellite models and the global circulation models, et cetera, is just our infrastructure for monitoring conditions on the ground, using good old-fashioned weather stations to measure kind of what rain actually fell in a given location, or how soil moisture is responding to a given precipitation event. And so, you know, when we think about this idea of first we need to know where and when to manage, one of the key factors there is our monitoring network across the state. And that's how I'm going to start this talk, is by talking about some of our monitoring infrastructure and the Montana Mesonet. And really what I think we all can recognize is that we need more stations across the state. And why is that? Well, I think the reason why we need more weather stations and soil moisture stations across Montana is because it's such a diverse state. We've got so many different ecosystems, so many different soil types, so many different ways that precipitation falls across the state in terms of not just snow and rain, but if it's a convective cell or a wider spread kind of regional precipitation pattern. All of these differences make Montana a really challenging state to monitor flood and drought. And a lot of the work that I'm going to be talking about in terms of expansion of our infrastructure has been coming out of some of these recent events, like in 2011, some of the dramatic floods that occurred across parts of the Missouri River Basin. And one of the key kind of aspects of those floods that has been recognized as a need is that we didn't have enough monitoring in the high plains, places like eastern Montana, where we have really important kind of low to mid elevation snowpacks across the prairies, and understanding of soil moisture conditions in these locations in eastern Montana that led to a lot of these floodings. And that there was understanding that if we had better monitoring in these regions, we may have had a more kind of accurate prediction of where these flooding and drought events may be occurring. And again, it plays into drought as well, like I was saying. And I think one of the questions was about kind of precipitation and how that might be impacting soil moisture dynamics earlier. And I think that this is a really key piece of drought monitoring in Montana that I think we can all recognize, is that precipitation has been getting more variable, and it's been falling maybe in a shorter amount of time. We're getting an inch of rain really quickly, as opposed to several quarter inches of rain distributed over a certain amount of days. And that impacts things like recharge dynamics in the soil and our agricultural drought conditions. And so we need more monitoring infrastructure to monitor real-time conditions and help us to better kind of quantify and leverage our models where we can. So the Montana Mesonet, as I know most of you are probably familiar with, is this really cool collaborative framework that we've been building out in the Montana Climate Office with many different federal, state, and private partnerships. Many of them are listed here, all the way from USDA to BLM to MSU Agricultural Research Centers to conservation groups like the Blackfoot Challenge, and partnering with the Mussel Shell group as well, along with private landowners. Be a really key kind of piece of this puzzle. And the Montana Mesonet is an automated weather network system across the state that measures soil moisture and precipitation, temperature, and other meteorological variables to help us to characterize conditions. And here, this is a bit of an outdated map. We actually have much more than 74. This is from 2019. We're up to about 110, I believe, now across the state. And what you can see is, of course, up near kind of Fort Peck and your all neck of the woods, we do have several monitoring stations, but we're excited to be expanding in this location as well. And so throughout this talk, I'm going to be talking about some of these kind of expansions of this monitoring network and efforts. And I would encourage you all, if you know of landowners or are your own landowner that are interested in kind of being a part of this process, please reach out to us, and I'm going to put some contact information at the end. And so recently, we've had the opportunity to have a really big expansion of the Montana mesonet through a federal Senate Bill 444, the Missouri River Basin Drought and Snowpack Monitoring Act. And this was an act introduced by Senator Thunes and Rounds out of North and South Dakota. And for Montana, this basically meant that we got a $21 million contract to expand the Montana mesonet. And this means 205 new stations across eastern Montana. So this is the cool thing about this project, is that it's focused on the upper Missouri River Basin. And again, like I was saying, this acknowledgement that we have a lack of data in the high plains in the upper Missouri River that really contribute to some of these extreme flood and drought events. And so they're focusing on these regions that are below 5,500 feet. And these 205 new stations in Montana are really exciting. They're state-of-the-art, really, really high grade, kind of research grade, climate grade weather stations that have 30-foot towers, like you can see in this picture here, with wind sensors, relative humidity and temperature sensors distributed across the tower. We have precipitation and snow measurements, soil moisture being measured at 5 different depths. And so just to give you an idea of what this looks like, here's just a bunch of pictures from some of our deployments of this recent expansion of the Montana Climate Office, mesonet, excuse me. And up here on this top left, you can see this is called the Pluvio. This is one of our rain and snow sensors. We also have snow pillow optical sensors that are measuring depth from above. These are some of our towers being installed. They pivot, and so they're able to drop down on a mast, so we can do Q&A on some of the sensors, for example. And one cool thing that we're doing with this is that they're built on helical piers. So these are helical screws, as opposed to a traditional big cubic foot of cement as a post. So we've eliminated a lot of the kind of land impact that is a part of putting up these kind of really large weather stations, because you need a really strong mounting block. And then you can see here, this is our soil moisture probe. This is just an example of how we have multiple soil moisture probes at different depths that allow us to characterize that whole hydrological cycle through that soil profile. So these are really cool stations that we're developing that we're really excited to partner with as many people across the state to get these out. So where are we in terms of this expansion? Like I said, 205 stations. It's kind of a mind bender for a lot of us in the climate office, because this is a giant project. I mean, it's at its core a construction project on top of this kind of really important scientific project. But it really takes a village to make this happen. And so in general, basically the 2019 to 2020 season, we put up a test station in Bozeman. And so you can see here, this is this map that I'm showing you here represents all of the grid cells, in which every single one of these grid cells is going to have one of these Montana mesonet stations in it by the end of this 5-year project. And so what you can see is that we started with this Bozeman station, and again, we're considering locations below 5,500 feet. So you can see these mountainous regions are kind of cropped out of the analysis, and that's because it's really meant as a monitoring infrastructure for that high plains region. And then in 2022, we put out 10 stations. So this is the 2020 to 2021 season, and then the 2021 to 2022 season, which was just this last season, we put out additional 8. And now going into 2022 to 2023, we're really starting to ramp up our deployment of these stations, and you can see them with these yellow stars. Are all sites that we've selected for this next round of installments. And then in 2023 to 2024, this is maybe what would be most exciting for you all. We're expanding, especially out kind of in your neck of the woods, out towards Fort Peck, and partnering with a lot of the tribal nations and different federal entities to put these on kind of representative locations that are going to provide really robust data sets for drought monitoring and flood monitoring. So we have a long way to go, as you can see, and we're all kind of sweating bullets over here to get this done, because it's a huge amount of work, but the benefits of a network like this are huge, right? And so collecting all of the data in the world is great, but it doesn't really help if it's not available, right? And so we're taking our first steps towards making these data publicly available, both for research and for development of additional tools that might be more impactful for producers across the state. And so this just is showing you the Montana Mesonet dashboard. And this is just a real-time dashboard that allows you to access precipitation, soil moisture data, models of the amount of evapotranspiration that might be occurring at each one of these locations, along with photos you can see to help us monitor rangeland conditions and kind of validate certain condition monitoring reports that we have been seeing across the state. And we're building out new tools currently to turn these into more usable kind of data sets for producers, things like growing degree days or cattle comfort index type kind of analyses and metrics to be more useful into the future. And so this is all publicly available, updates every 5 minutes, and is used currently in our drought models and our flood forecasting models across both the Montana as a state, but then the nation as a whole for river forecasting. And this dense network of kind of monitoring stations really helps us to do what we've been focusing on over the last 5 years in the Montana Climate Office, which is really enhancing our ability to monitor and assess drought across the state. And so here what I'm showing you is the Upper Missouri River Basin Drought Dashboard. And this was a dashboard that we developed in collaboration with folks at NOAA and NIDIS. And NIDIS is the National Integrated Drought Information Systems, in collaboration with many different entities, including DNRC, the State Library, the Forest Service, the GS, and NRCS, just to name a few. And what this is it's a drought dashboard that does daily calculations of modeling precipitation, temperature, snow, soil moisture, evapotranspiration, and various drought indices that really forms the backbone of our drought assessments every week, which then gets passed on to the U.S. Drought Monitor. And of course, these drought assessments are really important for our kind of agricultural drought disaster relief programs that we have federally across the state, and just general awareness of conditions and forecasting for potential kind of degradations. And so the Mesonet forms this basis to both kind of validate these models that we're using for drought metrics, but also kind of enhance their accuracy across the state. And what was really cool about the development of this tool is that it was a co-production of science with our partners. So every time we've been making changes or adding new data sets, they've been validated by our partners and kind of deemed useful for drought assessment across the state. And so that kind of brings us to kind of an important piece of this puzzle, which is what is drought? And drought is, I think we all probably have a conceptualization of what drought is and what drought means to us. But drought is, by definition, kind of a complex phenomenon, and it's difficult to monitor, and it's even more difficult to define. And that's because its definition really depends on perspective and kind of a system of impact, which is a challenging kind of topic and concept for communication, but also for monitoring. And so in general, we have 5 generally accepted types of drought. The first type of drought is meteorological drought. And this is the one I think that we all think of the most. This is precipitation deficits or hot, dry days, right, that are driving this prolonged period of dry weather. And meteorological drought is really that kind of first order driver of drought dynamics that percolate into all of these other forms of drought, which maybe take the form of, say, hydrological drought. And hydrological drought, I think, is the second form that we think of the most. This is dry rivers or low reservoir levels or low lake levels. These are kind of those meteorological implications for our hydrologic system. But then there's agricultural drought, which is probably the one that is most interesting to the producer community. And here it's when drought occurs and there's a water shortage that significantly damages or destroys, say, agricultural crops. And in this case, agricultural drought may be driven by things like soil moisture dynamics or the lack of water availability in the soil column. And so meteorological inputs obviously kind of drive those dynamics. And then there's 2 others, ecological drought, which is really that ecological implication of drought. forest mortality and death due to, say, really, really dry conditions or extreme drought events, or say a river drying up and fish being abandoned and having some ecological implication, especially hot conditions, and like what we see out in the Big Hole pretty frequently, those really, really hot water conditions causing mortality to brown trout, which all kind of fit under this umbrella of socioeconomic drought, which is basically how all of these different forms of drought impact the economics of our country and the globe. And so we can think of, it's easy for us to understand how agricultural and hydrological and ecological drought kind of impact our economy through the outfitting industry, agricultural and livestock production, et cetera. And so part of what makes drought such a complicated thing is that it has such a diverse definition. And when we have this like diverse, complex definition of what is drought, and we're tasked at the national level to kind of assess drought from all of these different perspectives, it really takes a lot of data to try to come up with a holistic picture of what drought is. So what data do we use in Montana to describe drought conditions? Well, we obviously use things like precipitation anomalies. So how much precipitation occurred with respect to what we expected. Temperature anomalies, is it warmer or cooler than normal? Atmospheric demand, this is how much the atmosphere, how hungry the atmosphere is for moisture. It's sapping water away from, of course, soil moisture that might be available for crops. Soil moisture anomalies, of course, are really, really important ones in Montana, and we're thinking about rangeland conditions. Snow water equivalent, this is, of course, really important in the West, but also in the East, and we're seeing more and more kind of acceptance of the importance of plains snowpack in drought conditions. Vegetation health and stress, this is vegetation dynamics that are being monitored from space using satellite information, and drought impacts reports. So these are impact reports that I'll put up a link at the end, but we have a Montana drought impact reporter that allows us to kind of ingest information from folks like yourselves to validate or kind of provide contrary evidence to what we might see in the models in terms of what you're seeing on the ground. And all of this goes together into what is considered a convergence of evidence. And this convergence of evidence approach to basically take all of these different pieces of drought and all of their different complex kind of ways that they can play out across the state and merge them together into what we call the U.S. Drought Monitor, which is a really challenging thing to do. And just to give you an idea of what kind of goes into these drought metrics, I just want to give you kind of a quick representation of how drought metrics are calculated, because I think it gives everyone a conceptualization of what we mean by drought from a quantitative state, from a mathematical perspective. And it's really this idea that we're normalizing data based on time periods of the same time period. And so what that means is if we look at a time series, this is precipitation in Helena that I just pulled, just showing you monthly precipitation. And if we wanted to calculate a precipitation-based drought metric for, say, July of 2019, we would compare what occurred in 2019 in July to the other Julys over that period of record. And this reference period defines kind of what we expect to see. We could do this over 30 days, 90 days, 180 days, 365 days, right? We can aggregate them over different time periods, and they're going to show us different representations of drought. So for in this location, I'm showing you a 30-day standardized precipitation index, or SPI. This is one of the common drought indicators we use that describes precipitation anomalies. And what you can see is in 2017, of course, we had a really extreme flash drought event, right? Things were really terrible, and they intensified really, really rapidly. And so you could see that signal here in the 30-day SPI, where we had a really dramatic decline in our precipitation anomalies, which created significant impacts across the state. Now, if we did this same analysis for 365 days, so using an entire year's long record, what you can see is that that 2017 drought event didn't even show up. And that was because it was based on this really, really short time in which conditions kind of intensified really rapidly. And so just to show you what that looks like spatially, I'm just going to show you, can you see my map now? Yeah. This is basically the UMRB drought indicators dashboard. I'm just showing you a real-time kind of demo of this, but this is the same metric, that standardized precipitation index metric across the state. And this is what we use to do our drought assessments. And what you can see is that the warmer colors represent drier conditions across the state, and the blue colors represent wetter conditions. And you can see that when I use a 30-day SPI or a 60-day or a 90-day metric, or even out to 2 years, we see very different representations of how dry conditions are across the state. And it's our task as drought monitors to basically assimilate all of this information into a single map, right? And what you can see is that the 90-day expression of precipitation anomalies doesn't really align with our US Drought Monitor map, where we see really extreme conditions in this red blob where my cursor is. That's more related to these 2-year metrics. And that's because right now we understand that conditions across Montana are the result of many years worth of precipitation and meteorological deficits. And so these short-term metrics that look very rosy and maybe look like there's no drought at all aren't what we're focusing on, because that isn't what is the dominant driver of drought across Montana for now. And so this idea of using different periods of record and different data sets and converging them into a convergence of evidence approach is really challenging, but really what we have to do as drought monitors, because drought is such a complex topic. So what does this look like? Well, each week we have a suite of drought authors across Montana. There's five drought authors across DNRC, Weather Service, the Climate Office, and the State Library. And on Sunday and Monday morning, one of us 5 basically come together and do an initial assessment. We draw out how we think drought might be changing across the state. And on Monday afternoon, we send that out to our drought listserv. And this drought listserv is a really cool thing. It's a collaborative group of people from across the state. Some of you may be on this drought listserv, and we'd be happy to have more people join the listserv. And this is a group of kind of trusted producers, agricultural scientists, managers across the state that help us to kind of validate the conditions we see in the models, and or provide contradictory evidence for maybe we're getting something wrong, say in Petroleum County, and that needs to be addressed using different data sets. By Tuesday, we get information back from our kind of trusted advisors on this drought listserv, make amendments to the map, which then on Wednesday gets sent out to the national drought listserv or drought authors at the US Drought Monitor. And that US Drought Monitor is, of course, the thing that triggers things like the livestock forage program. So these big agricultural relief programs that provide assistance during times of disaster. So this process every week is what really is driving that map, right? And we repeat this 52 times a year. So every single week we're doing this assessment, and it's quite a lot of work because of all of the complexities that I was just showing you. And so in general, kind of the takeaway is that it takes objective data, impact reports, and a well-justified argument to make USDM each week. And we do that as best that we can using all of these different data sets to try to most accurately describe conditions on the ground. And so we've been making a bunch of improvements to our drought monitoring infrastructure across the state, not only using stuff like the Montana Mesonet, but which helps us to kind of validate and create more robust tools and metrics and models of conditions across the state, but we can also use, for example, soil moisture time series. So this is from a station in Montana Tech, and it's just showing you for the same time period where we have this precipitation regime where we see kind of above normal precipitation. Understanding where that actually increased soil moisture is a really important thing, right? Because what we've seen a lot with climate change, and especially this increase in variability in precipitation, is that we have a lot of precipitation occurring maybe at once over a really short time period, and that just runs off and it doesn't actually infiltrate into the soil. And so having a good understanding of where these meteorological inputs are actually benefiting our hydrologic system is a key component to accurately describing conditions in Montana. And just so you guys are aware, this report just came out today, actually, and this is NOAA and NIDIS put together a report that kind of documented what occurred in 2020 and 2021 across Montana, the Dakotas, Wyoming, and going into Canada, this idea of this Northern Plains and Canadian prairies assessment. And if you're interested, I'll send along this URL, but it tells you something about kind of what happened and documents kind of some of the impacts that occurred across the state. And so in summary of this portion of the talk, and then I've got one little last thing that I want to talk about, is that our unique geography contributes to big differences in drought conditions across the state, and how fast changes are occurring, right? And accurate monitoring and assessment is a critical step towards, responding and providing relief during the bad years, but taking advantages of the good years. And as temperatures increase and some of the dynamics that Kathy was talking about play out, Montana is likely to see further decreases in water supply due to enhanced evaporative loss and reductions in soil moisture, groundwater, and stream flow. We've already observed those changes over the kind of observational record, but we're projected to see even more. And so that kind of brings me to this question of, well, how does climate change impact our assessments of drought? And this is something that is very this is some new research that we're doing to try to understand this question. I kind of want to introduce it to you just in broad terms. And it really starts with this notion of aridification versus drought and the differences between these two. And if we go back and remember what drought is and kind of the complexity of drought, the key takeaway from drought is that drought is a period of abnormally dry conditions, whether that's low rainfall, dry soil moisture conditions, etc. It's really that notion of relativity. It's an abnormality in conditions. And so to define what is abnormal, it's just as important to define what is normal for that location. So we have to have an understanding of what average climate conditions look like to describe what abnormal conditions are, right? And aridification is totally different than drought. Aridification is this long-term change in climate over a period. And aridification implies a drying. In certain places, we can actually have humidification where things are getting wetter over time. But in general, aridification is a very different thing. And this is not a temporary phenomenon, right? Drought is a temporary phenomenon. We come out of drought at some point. But aridification is a long-term change that we shouldn't expect to see a return to what we previously had, right? A previously wetter or drier climate. And so this notion of aridification and how it might impact our assessment of drought is really important as we start to see more and more changes. And to demonstrate this, I think it's easy to use temperature. But first, again, it's important to remember that drought is a relative phenomenon. I've beaten this home, but it's really important to remember that it's an abnormality. And it depends on a reference frame. And a reference frame tells you what normal is, right? Like, so for example, maybe it's the last 30 years, going back to 1990, might define what normal is for a given location. Or maybe it's going back all the way to 1895, say 125 years might define what normal is. And that definition of normal is really important because what if normal is changing? And if we don't update what we mean by what is normal with respect to drought, then a location may transition into a state where they're in perpetual drought or perpetual water surplus. And that's not what we mean by drought. A drought doesn't persist forever, right? And so when we think about what's happening in the Western United States, especially in the Southwest, this is a really, really big topic. There's a big shift in kind of the average conditions that have impacts for Lake Mead, water supply to Arizona, to California, right? These large scale kind of hydroclimatic features are changing. And shifting reference frames are super common in climate science. We've been doing it forever. And it's to describe this climate variability and change. And to really demonstrate this, right, this is showing you temperature dynamics across the country, going from the early portions of the 1900s all the way up to the most recent 30 years. And what we're doing is we're comparing average temperature conditions for a 30-year period to a 100-year, century-long reference frame. So the whole 1900 to 2000. What you can see is in general, temperatures have warmed in general across the country. This is using observed data from climate stations. So this is observed data sets, right? And so if we were to use this 100-year reference frame, we'd be more than likely to say every single year in this last 30 years was warmer than average. And while that's true from the perspective of the last 100 years, it's not true from the experiential reference frame of the last 30 years, right? We've had cold years, we've had warm years over that last 30. And so what's really important here is that reference frame that we choose to define our temperature normal here is really important. And we've decided as climate scientists that 30-year reference periods do a good job because they keep up with this climate variability and change. And so the question of drought monitoring is, why not apply the same concept to drought assessment, which is what we're not doing right now. Right now, we use really, really long reference periods to describe drought. And what that causes is, especially in the Southwest, we're overemphasizing how severe drought conditions are because there's this longer term climate trend that is basically impacting our perception of drought. And so what does this look like? Well, what I'm showing you here is a map of basically the difference between drought designations if you use a really long period of reference as opposed to a shorter period of reference. And the brown regions represent locations where we're overemphasizing how severe drought conditions are. And part of it is this climate signal, right? This climate change signal, which fundamentally requires a different response than drought, because drought is something that is temporary as opposed to a long-term persistent change. And so you can see in the Western United States, those brown areas are areas where we're overemphasizing drought in a lot of the cases with respect to this more recent climate period. In Montana, it's a lot less kind of clear. What we see is that there are some places where we're actually underestimating drought by using really long periods of reference. Actually, this blue area that's right around your neck of the woods is areas where, by using these really long reference periods, we're actually underestimating how severe drought conditions are. And so as a state, we've decided that moving towards this notion of a more contemporary climate record to describe drought makes a lot of sense. And it makes a lot of sense for a lot of reasons. It's really to provide the most accurate information about what drought severity actually is to producers and to water managers across the state. It provides realistic expectations of what we might expect to see tomorrow. And so that kind of concludes this part of the talk by suggesting that shifting to this notion of a 30-year reference frame or more contemporary climate to describe drought conditions achieves a lot of really important goals. It'll better reflect current day drought risk to affected communities, and it'll provide more accurate information about your own risk profile so that drought managers, water managers or producers can make their own decisions about what drought kind of risk they're willing to take. And it better will account for climate change in the future, which is a really important one because we're seeing dramatic changes right now. And we're shifting to a point where portions of, for example, the southwestern United States are just in perpetual drought. And that's not what we mean by drought. If we're not coming back out of drought, then it's a long-term shift. It's that aridification piece. And I think the key of this is that there's a real opportunity here to kind of reprioritize some of our perceptions towards drought, towards adaptation, as opposed to these kind of relief kind of paradigm, which is what we're stuck in right now. And again, in Montana, this has less of an impact. There's actually places where like I was showing you, the portions of central Montana were actually under declaring drought by using these really long reference period, which I think is a really important feature. And so we've been shifting towards this more contemporary description of what we mean by drought. But there's more kind of discussion to be had about what the best way to kind of address this idea of what drought means in a changing climate into the future. And with that, I'll just go ahead and say thank you. I think I'm just about out of time, and provide some resources and the email address, and I'd be happy to take any questions and or take on, if again, from the Mesonet perspective, if you guys know of landowners that would be interested in hosting Montana Mesonet sites, or are interested yourself in hosting a site, or being just a part of this conversation in general, we would love to hear from you and take any feedback you might have. So thank you very much.